Okay. The first problem says you have a wound that's healing at this rate. The area is given by pi r squared. It's decreasing. The radius of this injury is decreasing at a rate of 1 millimeter per day, right? So in other words, it's minus 1 millimeters per day at the moment when the radius is 25 millimeters, right? How fast is the area decreasing at that moment? So how fast is it decreasing? Speed is a rate of change. I'm looking at how fast the area is changing. And so what is it going to be compared to if I'm talking about how fast it is?
The rate?
The rate's getting compared to area over time. Right? So I want dA dt, but this is my relationship with area right now. My area just depends on the radius. Okay. I want to figure out how fast it's changing at that point in time. So my r is some function of time, I just don't know what it is. And if I take the derivative of that with time, I can represent it with that notation. Okay. I have area is pi r squared, but my r depends on something else, so this is still a candidate for chain rule. Chain rule says do the derivative like you normally would. And so what would you get from that? 2 pi. I drop the exponent, the inside needs to stay the same. So I still have an r, but it's an unusual input, right? It's a function inside another function, so I need to tack on what? The derivative of the inside, and so how can I represent that? dr dt. Okay, so now I have information though. I know that dr dt, right, when my radius is 25 millimeters, how fast is the radius changing? Minus 1 millimeters per day. Okay. And then I want to know what is the dA dt at this point in time when this is happening. So what would you just do with that information? Just plug it in. Okay, so you'll get 2 pi times 25, and then it's minus 1. What are the units for area if my radius is millimeters? Millimeters squared, and my time is per day. Okay. You could leave your answer in pi, it doesn't matter. If you multiply it out, that's fine too. It will be minus 50 pi millimeters squared per day. That's what your area is changing at, how fast it's changing at that point in time, once the radius has shrunk to 25 millimeters, and that's the speed that it's moving. Questions with this one? Okay. So find your partner for this worksheet. Go ahead and take a look at the second one, and I'll check in with you all with that in like the next 5 minutes. So give that a try.